Welcome back, everyone. Today we're taking a hand-drawn logic circuit and transforming it into something fully functional, first inside Tinkercad, and then as a real working circuit on a breadboard. This is one of the best ways to understand digital electronics: see the logic on paper, test it virtually, and then bring it to life with real components. Let's start with the circuit itself. We have three inputs, I1, I2, and I3. Inputs I1 and I3 go into an OR gate. Input I2 goes through a NOT gate, so we take its opposite. Then we feed the OR result and the inverted I2 into an AND gate. Finally, the output of that AND gate passes into one last OR gate, giving us the final output. It's a layered, multi-stage design, simple enough to understand, but interesting enough to analyze. To really understand how this circuit behaves, we built a truth table. Let's go through the results. When I1 is 0, I2 is 0, and I3 is 0, the output is 0. When I1 is 0, I2 is 0, and I3 is 1, the output is 0 again. When I1 is 0, I2 is 1, and I3 is 0, the output jumps to 1. With I1 at 0, I2 at 1, and I3 at 1, the output stays at 1. When I1 is 1, I2 is 0, and I3 is 0, the output becomes 1. When I1 is 1, I2 is 0, and I3 is 1, the output drops to 0. When I1 is 1, I2 is 1, and I3 is 0, the output is 1. And finally, when all three inputs are 1, the output is also 1. What's great about this truth table is that it lets us confirm that our design is working logically even before touching Tinkercad or hardware. Now let's bring this into Tinkercad. Once we create a new circuit, we add our OR gate for I1 and I3, a NOT gate for I2, an AND gate to combine the two results, and finally the last OR gate to produce the output. After connecting switches for each input and an LED for the output, we run the simulation. As we toggle the switches through every combination, we see the LED turning on and off exactly as our truth table predicted. This is the beauty of simulation: instant feedback, zero wiring mistakes, and total clarity. Once the design works in software, it's time to make it real. We move to the breadboard using actual logic chips, a 74HC32 for the OR gates, a 74HC08 for the AND gate, and a 74HC04 for the inverter. After powering all the chips, we wire I1 and I3 into one OR gate, send I2 through the inverter, and feed both results into the AND gate. Then we send that output into another OR gate and finally connect the output to an LED. When we power the board and flip the switches, the circuit responds exactly like the simulation and truth table. If the circuit doesn't work the first time, don't worry, check your power pins, confirm that no inputs are floating, make sure every IC has its ground connected, and double-check LED polarity. Once everything is connected properly, the whole system comes to life. And just like that, you've gone from a hand-drawn logic diagram to a verified truth table, to a virtual simulation, and finally to a real electronic circuit. This process is exactly how digital systems are designed in the real world. If you enjoyed the journey, make sure to like, subscribe, and tell me what circuit you'd like to explore next. Thanks for watching.